Sometimes with regressions, it's not as simple and straightforward as I showed you in the last videos. If, for example, we have this data set and we try to do an exponential regression, we try to take the log of y, we plug it into our calculators, we get an error. It says non-real answer. Why is it giving us that error? Because you can't take the log of a negative number. It's like asking 10 raised to what equals negative 7. You can't change the sign using an exponent, and so there's no real answer. So what we need to do is get rid of those negative numbers. So we're going to translate down. Now, these specific examples I'm showing you use certain transformations like translating down. Now, each question, each data set might require different types of transformations. These are just two examples. So if we go down, right, we have to figure out how far down we're going to go. So I marked the beginning. And let's go down 7. And we need to really be careful and record what we've done. So I can show you in the beginning or at the end what you have to do. Now, what we're also going to need to do, right, what we've done is made all of them negative, which seems counter to what we want. But now if we reflect it up by multiplying by -1, it does something like that, and it's all going to be positive. So reflect up, boom. And we can get all positive values then. Now what we can do is do an exponential regression using L1, L4, because those are now our positive values. And we're going to get that equation, which is going to fit those points very nicely. And if you say you're done, you will get the wrong answer. Because, of course, that's not the exponential regression that will fit our original data. That's actually going to be a horrible fit for our original data. So what we have to do is transform the equation in reverse order. When we transform the data, we translate it down first and then up second. So the equation we have to reverse. And what we're going to do is reflect up, or in this case down, right, because it has to be opposite. It's opposite direction in both sense of the word. So what we're going to do is reflect that down. You can see, boom, reflect it down. We do that by multiplying by -1 again. And you can see here's a negative in front of our coefficient. And now what we need to do is translate up, right, so that we're doing the opposite of what we did before. And you can see that's going to move our equation up and fit our original data hopefully very nicely. And we do that with this k value. This +7 is our translating up. And getting rid of the transformed data, you can see it actually seems to fit fairly nicely. And that's our regression. Now we're going to do a power regression using the same data. Power regression, as you know, requires taking the log of both x and y. Both have negatives, so that's going to be a problem. So what we need to do, it's going to give us errors. So what we're going to do is translate. Now, the last time we translated and reflected. This time we're only translating. That's what I meant in the beginning by saying each case is unique, and you have to figure out what transformations are going to work for that case. So if we move up 10, right, the data moves up so that the y's are all positive. And now if we move right 11, one of the points just got cut off up here, sorry. But that's going to make all the x's positive, just like that. And now we can do our power regression with L3, L4. Gets us that equation, and of course what we're going to have to do is translate that equation back to the original data by going in the opposite direction that we transformed the data in. All right, there's our original data. So we're going to have to translate left 11, which is going to move the equation over there. Left is the x, so it's going to be the h, which is always right next to the x, opposite sign. And now we're going to have to translate down 10, which is going to move that equation down into our original data. And the equation should look something like this. Now we do have to be a little bit careful, because with power functions, remember that there are ranges where it won't work. And what we've done is we have forced it to work in some negative zones, but if what is in underneath the exponent becomes negative, that could cause a problem. So this is going to have a restricted domain. All right, really, this equation is only going to work for x greater than or equal to 11. If it's less than 11, then we get a negative number and we'll get an equation that doesn't give us any results. So there's the two examples of transforming data so that we can work with negative numbers.